All right, welcome to the tutorial for the first coding task. This task overlaps two classes that I'm teaching, the Introduction to Computational Social Science, Module 1 on text analysis, and also the text analysis for social sciences, the PhD class for the Module 1 on pre-processing. Starting from the next task, the text analysis class will continue doing more text analysis, token and the document and the corpus, but the computational class will move on from text analysis to machine learning and social network analysis. So, oops, social network. So this is the only tutorial that'll overlap for the two classes. So, but the assignment for this one is the same. The data and the coding is the same. So bear with me. So the coding task instructions. First, if you can find these for the computational social science. You can find the instructions in the Module 1 text analysis coding task. So if you go in there, I've got the coding task instructions here, and I also have a zip file of all of the code. For the text analysis course, it's the same. It's in the pre-processing module, coding task number 1. You've got the instructions and the all of the files in the zip file. So, but first of all, before you download this and get going, let me just say the first step is to familiarize yourself with the documents. What are the texts that we're going to use for this activity? I'm going to look at two automobile makers, Li Auto and Rivian Automotive. Li Auto is a Chinese electric vehicle manufacturer founded in 2015. Rivian is a US EV manufacturer founded in 2009. I've got some YouTube videos here so you can see. What I'm trying to show you is that these companies are very similar in terms of their products. So Li Auto, possibly the best luxury SUV of 2023. So they're making electric vehicles, but on the luxury end, and also specializing in SUVs. So you can see here. So that's Li Auto's current line, and then you've got this is the 2023 Rivian R1S, which is also an electric Range Rover. You can see. Okay, so you see that they're both new EV manufacturers who specialize in luxury SUVs. So the text that I want to look at is their SEC filing. So Li Auto, because Li Auto is they're a Chinese manufacturer, but they are publicly traded on the NASDAQ. So any publicly traded company, American or foreign, has to submit an annual report to the SEC. This is the Securities and Exchange Commission, which regulates the stock markets in the United States. So if you're a foreign company, you have to submit your annual review is a 20F form. And if you're an American company, you have to submit a 10K form. But the format is quite similar. So for both, we're looking at the 2023 annual report for the 2022 fiscal year. So if you follow these links, you can see on the SEC website, this is sec.gov for the American government. This is the Form 20F annual report for for the fiscal year that ended in 2022 for Li Auto. And then if you go down here, right, you can see it's a Chinese company registered in the Cayman Islands. Principal offices are in Beijing. And you can see there's the table of contents here for this document. So it's a fairly large document, 163 pages. You can see all the sections here. So next, we'll look at the 10K, also an annual report for the fiscal year ending in 2022, Rivian Automotive, registered in Irvine, California. Also, you can see the table of contents here. Very similar structure to the Li Auto, to the 20F form. So this is the text. I copied and pasted this text and I saved it. This will be the basis of the these are the two documents that we'll do our analysis on. So first we need to do some file management. So you need to download the files from Moodle. We have two text files, the Li Auto file and the Rivian file. These are .txt files. You will save these in the data folder. And the code you'll save in the scripts folder. There are three scripts that we'll use. These are the IPYNB. This means it's a Jupyter Notebook script. If you look in my, right, what I did was create a project file called Module 1 Text Analysis. If I open that up, you'll see the three folders, right? Analysis, data, and scripts, plus the coding task instructions here. In the scripts file folder, sorry, you'll see the three Jupyter Notebook scripts. If I go back up to the data and then up to the project folder and then go down into data, you'll see Rivian and Li Auto. These are the original files. These tokens, I can delete these actually. These will be produced by the script eventually after I run script 1. But for now, like it should look like this. So if you go to the these out. If you go to the coding task here, you can download the zip file. You can choose a folder of your choice. So I'm going to go to courses here. Right, let's say the computational social science course, coding. Right, now let's say I'm just going to save the folder here. Right, and then open this up. And then I can extract it. So okay, so here's the zip file. Here's the text analysis. All right, it's like 1 deep. I'm just gonna move this up to the main. Okay, so you can see I have a project folder called Module 1 Text Analysis. And if I open up that folder, you'll have the scripts, the analysis, data, and scripts folder, plus the instructions. You open up scripts, you should have the 3 scripts in there. If you open up the data, you should have the 2 data files, right? Oops, sorry. So that's fine. So, but you just need to make sure that you know what your project folder is, and then that the folder structure, that you have these 3, and that the data files are here and the script files are here. Right. If not, you might get some file not found errors. So please double check that the structure is fine. And once you've done that, all right, now you've downloaded the files and the folder structure is correct. Now you're going to conduct your analysis in Jupyter Notebook. So we're going to do a keyword analysis and a sentiment analysis. But right, so first you're going to open Jupyter Notebook. Right now I'm using my Windows Explorer, to navigate here. But you're going to open up Jupyter Notebook. You're going to find the preprocessed token script, and you're going to open that in Jupyter Notebook and run it first on the data, on the two documents that I showed you. This script will output a tokens, cleaned and processed file containing the tokens for each document. So, and you're going to, and that document, the tokens are what you'll use to do the token frequencies analysis and the sentiment analysis. So first you have to run script number 1, and after you have the tokens, then you can run 2 or 3 in either order. It doesn't matter. These are you can do that. You use script number 2 to do the keyword analysis and script number 3 to do the sentiment analysis. So, but first things first, we have to do we have to pre-process the tokens. So to do this, we don't open the file from Windows Explorer or for Mac Explorer. You need to go to open your Jupyter Notebook. Everything's running slowly because I have so many documents open. Let's see. Okay. These assignments. So I saved everything in my Dropbox. Courses. Okay, here's the zip file, right? Here's the main project folder, module 1 text analysis. I'm going to open that up. Scripts data analysis. I'm going to go to scripts, and I'm going to open preprocessed tokens. Okay. So I'm going to start by importing some libraries. I'm going to need the RE library, the NLTK library, and some libraries within the NLTK, such as Corpus, Lematizer, WordNet. So if here you can see I've commented out this line. If you've already imported RE, you can just start running these, right? And it's importing it, and once that star goes away, and this turns blue, or sorry, a number comes here. Now that's been imported, right? You can move on to the next one. But if you've never imported these before, you'll need to import it the first time, or sorry, install it the first time. So to do that, you'll comment out, you'll delete this hashtag, right? And then you'll run this. You'll see if I run it. I've already installed RE, so it should tell me that I already have a copy, right? So could not find a version that satisfies the requirement. No changes. I've already installed RE, so it's going to give me an error. But so I'm just going to put a hashtag here. But if you've never done it, you need to run it. And after you've run it once, then put the hashtag there again. So in the future, you don't have to run it. You only need to install it once, then you can import it. Okay, so I import this, run this. Okay, run this, this. This is just getting prepared. These are all the libraries and tools that I'm importing to tokenize, to lemmatize, etc. Downloading all the stop words, etc. So once you've done this, if you didn't generate any errors here, then you have all the tools you need. So now we're going to data path. Remember, all of my data is in the data folder. So I had created this data path variable. Now here I'm gonna run the script once all the way through on the Rivian text file. You can see I've commented out the liauto file. So this time around, I'm gonna run the script just on Rivian to produce the tokens for Rivian. After I've done that, I will save that, I will close this file, run it again, and then run it on liauto instead. So, but for now, let's run it on Rivian. So the file name will be Rivian. You can verify that here. Okay, so let's open the file, read the text from the file into a text variable, and let's look at the first 1,000 characters of that. So here are the first 1,000 characters of that text file. You can see there's uppercase and lowercase. You can see I have \n. I've got, which is a line break. Dashes, numbers, punctuation. It's pretty messy. Here's some tabs. \T is the tab. So it's still a lot of noise in there. Okay, and then the analysis path, we don't actually need this in the script, but I just have it here. Okay, so our first step, now we're actually going to start pre-processing. So step one is to replace all the white space characters with a space. White space characters include things like line breaks, tabs, and these other things. So it's white space characters have a backslash and then followed by N, a T, an R, an S, something like this. So I'm gonna replace all those white space characters with a space. Now you can see the text. This is an example of the first 500 characters of the text before I removed the white space, and you can see it has things like this \n in there. But after, now it has none of these \n, \t things are here anymore. I just replaced them with a space. So that cleaned up quite a bit. Okay, now let's make everything lowercase. So I'm going to take the text, this new text 1, make it lower and save that as text 2. So before text 1 looked like this, it had uppercase and lowercase. Afterward, everything is lowercase, right? So step 2. Step 3, I'm going to tokenize the text. So I will run on the NLTK library. I'll use this word, the word tokenize function on text 2 and save that as text 3. And then the number of tokens in text 3 you'll see is 70,000. So there's 70,000 tokens from the Rivian document. And now before we tokenized, the text 2 was just one big long string containing everything. Now that we've tokenized, it's text 3 is it's a list of words, right? But it also includes punctuation. It includes numbers. It includes abbreviations. It includes like these form numbers, etc. So all of this stuff has been like this mark 1 box. Now the parentheses, the mark, the 1, the parenthesis, and the box have all been tokenized as separate tokens. Okay, but you can see we still have a lot of non-alphanumeric tokens in here, and also tokens that are length of less than 3. So for example, like OR, TO, any like very small OF. I might remove these later with stop words anyways. But I can also just remove any token that's like less than 3 characters long. And I can also remove like non-alphanumeric tokens. For example, like these boxes or punctuation. So I will do that for any token in text 3, which is not, if it contains any only tokens which contain alphanumeric characters, right, and are larger than 2 in length. And I'll save that as text 4. Okay. So now you can see before filtering, I had 70,000 tokens. After I've filtered these alphanumeric tokens, I have 49,000. The tokens before I filtered out had, punctuation, boxes, big little things. Afterward, notice all this freestanding punctuation is gone, right? I do have periods like in DC, like in Washington, DC, right? And I also have a period here in the file name because they belong there. But the parentheses are gone. These little boxes and these little, non-alphanumeric characters are gone. Okay. Now we're going to lemmatize. Lemmatizing, as you can see, takes things like securities and turns them into a singular form, or stems, verb stems, it converts them into their infinitive form. So I'm going to lemmatize every token in text 4, which was my last one, and I'll save those as text 5. So here, lemmatizing doesn't delete anything, but it does change them. So the number of unique tokens before lemmatizing was 4,800. Now, after lemmatizing, the number of unique tokens is 4,300. So there were 500 tokens in there who had the same stem, but were, in a slightly different form. And so lemmatizing made those all the same. So now if I show you here, right, like United States turns into state, securities turns into security. Okay, so lastly, I'm going to remove stop words. So I have my stop words list, and for any token in the text 5, which is not in the stop words list, I'll include that in 6. If it is in the stop words list, I'll exclude it. So I can run that. Now, before removing stop words, I had 49,000 keywords. After removing stop words, I have 37,000. So this also cleaned up more than 10,000 keywords. And you can see some of these. So these are some of the stop words that I've removed from this text. So like and these are some of the removed words. So I removed this, then, there, that, then, all, the, only, such. These have all been removed from this text. So which means I'm left with this. So it reads a little bit less like a sentence now and more like a series of words, tokens, right? United States Security Exchange Commission, Washington, D.C., blah, blah, blah. Mark 1 annual report pursuant section security. So these tokens are much cleaner now, but it's lost its sense of being like a sentence or a structured text. Okay, lastly, I can do parts of speech and filter out any unnecessary parts. So this is the list of the parts of speech in the Python library. So first what I'm gonna do is tag every token here as a part of speech, right? United States Security Exchange Commission. So here, if I run this parts of speech tagger on text 6, I'll save that as POS, parts of speech. And you can see United States Security Exchange Commission, Washington, D.C., everything's been tagged, right? So JJ is an adjective, right? United States. State is an N, which is a noun singular, right? So if you, so you can look at like MD. What is MD? Modal. So what is modal? If you want to find that, you can type in, MD here, and it'll show you MD. All of the MD words in our list of tokens here include would, could, must, oversight, shall. So are these words that I want to keep in the analysis? Like, I don't think I need these, right? So I'm going to exclude MD. I'm actually going to exclude quite a few of these, right? What do I really want to keep? So I want to keep foreign words, adjectives, nouns, verbs. So these are the things I want to keep. Anything that's not on this list, I'm filtering out. So right. So for each token, for each pair here, if this second part of the pair is contained in this list, then keep it. If not, reject it. So run that, and then you can run. I can run this. So before filtering on parts of speech, I had 37,000 words. After filtering on parts of speech I didn't want, I have 34,000 words. So this is good. Okay. So one last comparison. Before processing, I had 71,000 approximately tokens. After processing, I cut that down by less than half. Right? And in terms of unique tokens, of these 70,777, only 5,046 of them. Yeah, so there were 5,000 unique tokens. After processing, they're now like 3,700. So a lot of tokens have been removed during this process. And now I'm going to export the process tokens. If I run the file name, I can confirm I'm looking at Rivian. I'm going to create a prefix from this, which is Rivian. And then I'm going to construct a file name for the tokens called tokens Rivian using this prefix Rivian. So with this new file name, I'm going to write the tokens out to this file here in the data path, right, into my data folder. So if I run that, it's done. Okay. So I'm going to go look in my data folder, and I should see now. Oops, am I in the right? I think I saved several copies of this. So where am I? I think I was in the computational social science class. Oh, where's my script? My script is located in computational social science coding. Okay. So okay, so I'm in computational social science. Oops. Coding, text analysis. Now, if I look in data, I've got that tokens file. If I open this up, this will have the 3,400, 34,173 tokens after processing. So let's open that up. So United States Security Exchange Commission, right? These are all the tokens that were in the Rivian form, and you can see there are can double check the word count. We can check. I mean, it has that many characters, but not many. How many rows? Maybe if I open it up in Notepad++. So what we're looking for is to confirm it's 34,173 rows. And you can see 34,174 rows. Yep. So it's 173 plus 1 for white space at the bottom, I think. Right. So this is the complete file. It contains 34,000 tokens. Yeah. So okay. For now, so we've created the tokens file, right, for Rivians. Now we need to create the tokens file for Li Auto. So I'm going to save this, close it, run it again. Okay, so I can go through these all again quickly. But here I need to change the file name, uncomment Li Auto, and come through and double check the file name. It's Li Auto. So let's open this file. Move the text into the text structure, and the first 100 lines are United States Securities and Exchange Commission by its right. It looks like the last one, but remember now this is a Form 20F, and Li Auto is going to be in here somewhere. Right. So we've downloaded the text. Here's the analysis path. All right, so replace all the white space, right, before and after. So you can see the white space has been removed. You can do lowercase. This is before, this is after. Right, so this is all these are the same data, just yeah, so I'm sorry. So this made everything lowercase. In step 3, we're going to tokenize the text. So here, instead of 70,000 tokens, we're going to have 178,000. So this is a much larger document. This is what it looks like before we tokenize, after we tokenize. Before we tokenize, it was just a single string. After we tokenize, that string has been chopped up into individual tokens. We're going to remove all the non-alphanumeric ones. That removed about 50,000 tokens, right? From 178,000 to 126. So before this included things like parentheses. Now those parentheses are gone. It's much more dense. Things like boxes, they're gone. Now let's lemmatize. So okay. So I'm dealing with 126,000 tokens, but there are only 8,000 unique tokens and then after lemmatizing, there are even fewer. Right? So having lemmatized, securities went to Security Exchange Commission, Washington, D.C. form. Okay, so now I'm going to remove stop words. Right, that moved it. That moved that removed about what 40,000? No, sorry, 30,000 stop words. So now this is an example of some of the words which were removed. And okay, so these are the first 200 words of that document. I'm going to do the exact same thing with parts of speech tagging. So right now I'm tagging, it's running, so I'm tagging all the tokens with the part of speech, but there are a lot. There's like 120,000, so it's going to take a minute. Okay, so that's done. Right, so we've tagged them all. for the part of speech. Now I'm going to look, what does the MD include in this one? Basically the same things. So I'm going to, let's see, I'm going to exclude the same parts of speech and include the other. I'm going to keep nouns, verbs, adjectives, stuff. I'm going to get rid of other ones. Okay, now I'm going to apply this for any token that's in here. Pre-kept. Let's see. I'll keep those, and any ones that not that where there's not, I'll discard them. So once I do that, I go down from 93,000 to 84,000. So it's still cleaned up quite a bit. If you compare all overall, I started with 178,000. Now I've only got 85,000 approximately. 8,600 unique tokens. Now I've got 5,587. So these numbers aren't too far off from the Rivian data. Okay, so double check the file name is Liado. I'm going to take the Liado part of that, create a tokens file name for it, and I will write it out. And if we go back to the data, you can see we've got the Liado one. How big are these files, by the way? So let's look at the size of them. Right, the original data files were about a meg and half a meg. These lists of tokens are much smaller than that, not even a full meg. So they're pretty lightweight. I mean, yes, there's 37,000 lines, but somehow, yeah, been parsed down quite a bit. Okay, so this is done. So we're done with this, and the next, so should say this is the pre-process. Oops, I'm not going to mess with that. In any case, so we pre-processed the tokens. Now we have to do a keyword analysis and a sentiment analysis. I'm going to stop the video right here at this point where we pre-process the tokens for these documents. And then I will create a second video which discusses the keyword analysis and sentiment analysis, which uses these second two scripts.